Oval is MEV capture or Oracle price updates, and Aave liquidation creates a MEV opportunity. This revenue is not insignificant. As your protocol gets used, you have like this MEV exhaust. That's currently getting lost. If you can efficiently capture the MEV that your protocol does leak, you can use it as a business model to drive your protocol in a sustainable way.
Hey everyone, this is Sina with another episode of Into the Bytecode. My guest today is Hart Lambur. Hart has worked on a number of really interesting crypto native protocols over the years. We start this conversation by talking about UMA, an oracle which uses the idea of a schelling point to bring data on chain. And we talk about Across, a bridging protocol using an intense-based architecture to connect Ethereum and other layer 2s. Then we talk about the latest protocol they've built called Oval. Oval does MEV capture for Oracle price updates. Now, I know all of this sounds pretty complicated, but we take our time to talk through what they really mean and how these protocols work, and also the path that Hart took through building each of them. I do want to say that nothing we talk about here is financial advice, and that my guest and I may hold positions in the assets discussed. And with that, I'll leave you to it, and I hope you enjoy the conversation. Into the Bytecode is sponsored by Privy. One of the biggest problems we're grappling with as builders working on crypto-enabled applications is how to make the right trade-offs between user experience on the one hand and security and privacy on the other hand. How do we promote self-custody and ownership while letting the application shine rather than the crypto behind it? So Privy plays an important role here. They provide simple onboarding so anyone can connect to your app easily by allowing them to sign in with an existing wallet or by making it easy for you to provision a new self-custodial wallet for them, linking to social logins like Google, Twitter, or Discord. I personally have faith in Privy because of the team. Henry Stern, who's one of the co-founders, was previously on an episode of this podcast, so you can listen to that conversation for more of a deep dive. And he and his partner, Asta Lee, have been thinking about data privacy and security for a long, long time. And you can see this in the level of thought they're putting into the product. So if you're working on a new product and thinking about how to reach a wider group of users without compromising on either user experience or privacy and security, then I encourage you to check out Privy at privy.io. I've been going down a massive rabbit hole with the different projects you've worked on over the years. And I thought a good place to start would be if you could tell me the story of, how the different kind of chapters that you see in your time building in crypto with UMA, with Across, with now Oval, and the kind of idea maze that you've been traversing through this period, what the kind of key moments of insights have been, what the big inflection points have been. I realize this is a big question and we might spend some time on this, but I think it's a super interesting place to start, and I'm really curious about it personally.
I think actually what's useful context for your listeners to know is like my background before crypto, where like I studied computer science, so I am a technologist in that sense. But then I worked in finance at Goldman as a interest rate trader. And this will come back when we talk about like RFQ systems and order flow auctions. And literally, my job at Goldman as a rates trader was like the old school RFQ system for providing liquidity with like humans clicking buttons. And
Wow.
you can kind of see now how we are encoding that in protocols, right? Um, and so it's really kind of hilarious. It's like the 20-year forward version of how that used to work. So the uh, Goldman bond trading RFQ market maker is informative. And then I started a fintech business after I left Goldman. Um, that's also kind of informative because, frankly, around that business, there were like some like legal issues. Like I
Mm,
got sued unfairly. Ended up winning it all, but I sort of saw how unfair the court system was in a sense,
mm,
which is also really interesting. And that kind of triggered like, hey, smart contracts and smart contracting can be a better way of writing certain, at least many types of agreements. Is that
Yeah.
okay? So that's like pre-crypto. Uh,
So you were perfectly primed.
so what I was primed for, well, is in 2017, there was no concept of DeFi yet. Um, I had a finance background and a tech background and a fintech background at that time. Um, and remember, like crypto founders at that time, like they were kind of like they all had long hair and were like cypherpunks and were like real like. And I was kind of like the Goldman guy. People
You
didn't
want to
quite,
disrupt nation states.
yeah,
And you're like,
exactly.
I just want to build a better banking system.
Just the future of finance, right?
Yeah.
Uh, and right then you're like, well, wait. I had this understanding that the vast majority of finance is like contracting. It's every derivative trade is a contract between counterparty A and B, and those contracts are kind of like imperfectly written. This also goes back to financial crisis, and like I'm sitting on the Goldman's desk. I'm not the swaps desk, but the swaps guys were right beside me, and they literally had no idea what their risk was because all of these swaps contracts were like didn't know whether they were going to be honored or not, right?
Yeah.
Because they were legal agreements that just you just didn't know. And fast forward, you're like, okay, well, wait, if we put these on a blockchain and you could independently verify whether they had enough collateral or not, this seems like a strictly better way of doing finance.
Yeah.
And it is. So back in 2017, thinking about this, and it's like, well, if we could automate this by writing the rules of the contract on a blockchain, and if we could collateralize it using digital money, right? So remember, the other problem in the traditional system is moving money takes time. Like basically, the best you could do to like re-collateralize or to post margin in the old world is like once a day, maybe twice a day. Like you can't move money that quickly.
Yeah.
So and because of that, the whole margining requirements for the contract are higher, right? Like
Hmm.
if you can only update it once a day, you're going to need to post more margin in case that day things really move against you or whatever. So, you zoom out and you're like, all right, well, if we put the rules of this contract on a blockchain and we have digital money so we can do real time margining, you can have a more efficient and more transparent and more secure derivative contract.
And that's a pretty exciting idea of seeing that having been in the previous world where you're like, this is the proverbial 10x improvement on how things work currently, if not
Yeah,
100x.
it was pretty surreal, so this is like 2008 yeah era. The Goldman Sachs swaps desk, which is best in the business. I'm biased in my opinion. They're very good at what they do. And they're sitting there on Sunday. Markets aren't open, but we're there on Sunday in the middle of the crisis, and they like have no idea what their risk is. Like they just have no idea who's going to honor what contract, and so you have this book of swaps trades that's like tens of thousands. I don't even know how many contracts are in there. Like huge number of hundreds of thousands of trades, and they're guessing right what their risk
Yeah.
is because they don't know what's going to happen. It's not a good way to have a like a smooth financial system,
Yeah.
right? Uh, yeah,
I can almost feel the visceral sense of that, of like being like, this is the state of the art. These people are this is, the best in the world infrastructure and people, and we have no idea what's going on. It's almost like
yeah,
when you get a peek behind the curtain and you're like, holy shit.
yeah. And like legal contracts are messy. Um, um, there's a lot of infrastructure. So like since then, like Dodd-Frank and all this other acts, they're like trying to have like clearinghouses that basically instead of me directly facing a counterpart, we face clearinghouse, and that should like net risk off and like make things a little bit better, but really complicated. And there's just all this wiggle room that we just see, including in like centralized exchanges in crypto, right? Including like three arrows type like agreements, right?
Yeah.
legal contracts have a lot of wiggle room. And people will take advantage of that legal wiggle room. And it creates some big ass messes every so
Yeah.
often.
Yeah.
Um, so, I do think I think people that um, understand deeply how like messy the kind of derivative based system is, including many of like my old senior colleagues, they are very intrigued by a blockchain based world, where this is much more deterministic. Like that makes sense and feels again like a 10x or 100x improvement, in terms of how risk is transferred, and
Yeah.
recorded.
So you're like, I actually want to build these financial contracts, but the first thing I need is external data. Um, there isn't a good solution out there that's, generalized enough. So we're going to solve our own problem and build this thing. And
Yep.
then, the design of UMA is like super interesting too. It's like basically you're getting folks to, well, it's an optimistic system. So well, I'll let you kind of talk about it at a high level.
Yeah.
But it uses the idea of a Schelling point in there. It's got, crypto economics in the design of it. It's a very cool system.
So there's two layers to this, right? And like we've borrowed both layers from other smart people. So the first layer where we actually started is this Schelling point idea, which we borrowed slash stole from Vitalik, who wrote about this in like 2014.
Yeah.
And there's another guy, Paul Cesarek, I can't pronounce his name, but he wrote about
Yeah.
something called Truth Coin before that too. He's like an old Bitcoiner. But basically, the idea is that if you have people vote in secret about what the right outcome is, the right outcome will be the Schelling point. They'll agree on the Schelling point that they all coordinate on will be the truth. Um,
Yeah.
and you can prove this with game theory. It's pretty interesting, right?
Yeah.
Um, and so then there's another really clear and cool use for blockchains here, where we can use the blockchain system to give everybody voting tokens. And we can design a system where they vote in secret and then later reveal it, which is this like commit reveal scheme. And we can program that in the blockchain. And that's actually what UMA did. And that's the point of the token. Like the token is not a random kind of governance token. I mean, we're voting with it, but it very clearly has like a crypto economic use case in terms of how we're using our tokens to arrive at a Schelling point. And that Schelling point, we can show via game theory is the truth, right? So that's like really pretty cool. The problem with this, and so in essence, like then we kind of had the outline of this idea way back in like 2018. Um, uh, the problem with this Schelling point voting system is that if you needed this for like every price update, right, it would be way too slow. It basically
Right.
takes like two days to realistically 2 days to run this system. That doesn't work very well for a lot of use cases. And it's expensive because you have all these people doing this on-chain activity. So like gas costs here are real. So we came up with an optimization that we called the optimistic oracle, which was a very simple concept and just think literally like optimistic roll-ups. And like the optimism team helped us like work through this way back
Mm.
in the day too, where very simply somebody would propose a statement as true, with there's a bond there associated with it. If nobody challenges the statement within some challenge window, it gets taken as true. But if somebody challenges the statement, it goes to the Schelling point layer where everybody can vote on it.
Yeah.
And so it's like an escalation game.
Yeah.
There.
And weirdly enough, it seems like it works, right? It's been live in practice. It's being used by Polymarket, the prediction market, for settling their markets. It's used by Across, for bridging. Um,
Yep. So it works shockingly well, as a way to get um, data onto a blockchain, provided you can stomach that data not being available for like a couple hours, right?
yeah.
So here's where, and this will lead into like oval stuff too, but like if you need the price of Ethereum like now, Chainlink or some other Oracle providers work pretty well. But if you need something that Chainlink doesn't have a price feed for, um, or kind of need an answer to call it like arbitrary or long tail data, and you can afford to wait 2 hours ish, we have a really elegant solution that works surprisingly well and is also like cheap from a gas perspective in the optimistic case.
Yeah.
So, like you said, it's been live since 2020, which is
Yeah.
kind of crazy to think about. And we've processed tens of thousands of requests. Polymarket we uses us to resolve their prediction market outcomes, and then across the cross-chain bridge that we also work on uses the optimistic oracle in a very specific way to kind of do like very batched message verification that maybe we'll get into this. I'll call it like we verify intents. Intent's kind of a buzzy word, but we verify cross-chain intents, whether they're fulfilled or not. And the
Yeah.
optimistic oracle works really well for that too.
You kind of like crossed this Rubicon in 2020, which not many people have, which is getting a real smart contract application working and surviving for 3+ years at this point, which is like a pretty, it's a pretty impressive thing, given how kind of nascent these systems are.
There's two things that I am actually pretty proud of, like the team of people I work with for doing. Like thing one, we raised a $4 million seed round in 2018, which was like
Yeah.
depth of the bear market following like the 2017 crash. And we said we were going to use that to build to build and launch the UMA network. And we actually did that. We used just that money to build and launch the UMA network in 2020, right? Which when you look at some of these other projects, the amount of money that gets raised and all that is kind of insane. So we did that
Yeah.
with our $4 million. We built and launched our network, which I was pretty proud of.
That's
And
pretty
then,
impressive. I mean, that's pretty efficient given like all the kind of engineering and the audits and the legal input. Like, there's a lot of shit that goes into this.
I mean, again, when I look back in hindsight, I thought we were like pretty, we were pretty efficient. Yeah.
Yeah.
And also timeline, like from kind of like closing our seed fundraise to actually launching the network was like 18 months too.
Yeah.
And given the amount of kind of like random research we were doing, I thought that was pretty efficient. So like it was kind of a fun time, right? Like you go heads down, there's sort of no pressure because, well, there's pressure to just build, but we were just like, it was a very productive, diligent time of just like, hey, we're going to work through this. And then, we launched the UMA network in, end of April 2020. And that was cool. And then in terms of surviving between now and then, like there's some roller coaster, like some highs and lows there. Particularly like keeping talented people around our team and all that. But we've had great retention and we've had people that have been really excited about what we're working on. And I think the reason for that is like when you zoom out and you think about like how blockchain systems would work, the need for something like an optimistic oracle seems very obvious. Like we're going to
Yeah.
need some mechanism to get data onto a blockchain in a decentralized way. Um, and we're going to need something for arbitrary or long tail data, right? Like,
Yeah.
um, and again, I'll keep repeating like Chainlink has worked really well for price feed data, and like will when we talk about Oval, that'll come up more too. But for all the other types of like long tail data, like you can't use Chainlink to power prediction markets, and so when you kind of think about that, there seems like just an obvious use case for what we're doing.
Yeah. Well, I find often the best ideas are actually quite simple. They're you can describe them in one line and they just make sense once you hear them. And I feel like actually, that could be said about all of the things you've worked on. Like across also is, it's like, you know, bridging between all of these layer twos and Ethereum, and the mechanism, as I was kind of spending more time understanding it, just makes a ton of sense, you know?
Because your audience is pretty nerdy, right? Uh, a cross is a cross-chain bridge. However, we call it an intent-based bridging architecture. Intent is a buzzy word, but we are actually using it, I think, in the right sense here. And so what that means is a cross is bridging a value between blockchains using a third-party actor we call a relayer to fulfill that user intent. The more expansive kind of understanding of how this works, right, is if you think about bridging between two blockchains, the idea is you deposit on one chain. So you have some transaction to deposit funds on one chain. Then you have this like magic middle thing, and you somehow end up on this other blockchain, the destination chain, and there's going to be some transaction to send funds to your wallet. Okay, so the magic middle thing here is where, when you sort of naively think about this and the way most bridging or messaging systems work, is in the magic middle, we are going to send a message from origin chain to destination chain.
Mm-hmm.
And that's all well and good, except like it's not easy to do. It's like to send a message between chains, to send it cheaply, quickly, and securely, very hard to do.
Mm-hmm.
So the alternative architecture is like, well, okay, what if we don't send a message, or at least don't send a message right away? What if instead we have a third party here, the across relayer, SwapX calls them fillers, searchers, solvers, third party actor. What if instead they front the user money out of their own capital to fill them on the destination chain? Okay, well, if they do that, they can fill the user really quickly. And getting a little technical for a second, the gas cost of this so far are really lightweight. There's like a really lightweight user deposit transaction and a really lightweight a relayer fill transaction to fill the user. So I have cheap gas costs, and I can do this really quickly. Other nerdy side note, relayers can actually take finality risk. Like if they think that there's not going to be a reorg on the origin chain, they could fill a user faster than like chain finality happens,
Mm-hmm.
because they're assuming that risk. Can kind of go into that later. But great, the user now has a cheap and fast fill. They're really happy. Trade-off here is the relayer hasn't been paid back yet. So the relayer is making some loan, but we can kind of take our time paying the relayer back. And importantly, if we batch together a bunch of relayer repayments, we can actually slowly or optimistically verify those repayments, which might be secure and cheap. It's not quick. So it's not quick, but it's secure and cheap. And we can save gas costs also by batching many of these kind of verifications together, which also saves a bunch of money. And so we have a trade-off here where the relayer isn't getting paid back quickly, but it's secure and it's cheap. And then it turns out when you do the math, like if you have somebody make a loan at a 10% annualized rate for an hour, that cost is a tenth of a basis point. It's nothing, right? So we kind of hacked all the trade-offs here where the user gets a fast and cheap flow, but across like the relayer makes a loan, but when you add together all the optimizations here, it's way better than not having this relayer make this loan.
It's such a cool system design. I feel like it's like the archetypal crypto design, because you kind of like learn to not think of these, not try to control every moving part of the system, kind of like and mechanically make them fit together. And instead, like the design can include these external parties which basically appear out of nowhere if you give them the right incentives. And so, and what you said about these fillers thinking about taking risk with the finality of the origin chain, like the kind of default vanilla way to solve that would have been, we're going to wait for X many blocks based on whatever the consensus mechanism here is and the economic finality, and just like a really rigid, old world kind of design. Whereas here, by basically opening it up to be a market where, each one of these individual people can come, or individual actors can come and underwrite that risk on their own, right? And be like, I'm willing to fill this order because I know that I'm going to get paid this much more when I actually get paid in the future. And that, evaluating my potential loss, potential gain, and the probability distribution of that, and the expected value I imagine I'll get from doing this makes sense to me. So I'm just going to do this. And you allow these fillers to compete with each other, like if they have advantages versus each other, like it builds an efficient market where it basically gives the user the best possible price and execution that they can have.
And it is still shocking to me, even knowing all of this and knowing that like competition works and all that, it is still shocking to me how well this works. Actually, the whole
Right.
team, right? Like the weird optimizations relayers, fillers in our network are doing to fill users and like win more trades are mind blowing. Like I don't even know technically what's going on. There's like I need like, you know, my CTO to explain some of this stuff to me.
Yeah.
And he doesn't even like, we don't even really know. There's like weird compression and then like call data packing. I don't even know what's going on, but like people are going deep to compete to win more of this flow. Um, and I think that's pretty cool. Um, because like we have this very intellectually honest audience that you've got, it's worth talking about some of the trade-offs here too. And one of the trade-offs is that in this world where you require capital to be a relayer, um,
It's
some
not
people,
accessible to every participant.
yeah, they rightfully worry that this is not accessible to every participant. And
Mm-hmm.
and then there's sort of a centralization vector here where you end up having just to kind of name names and kind of bring the boogeyman into the picture. It's like Citadel and jump trading and da 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 that are like the fillers or relayers here, and you don't have this like democratized financial system anymore.
Mm-hmm.
Um, and I actually have a lot of sympathy for that argument too, because I think it's really cool how in uh, the early versions of DeFi, it's like a 14-year-old kid in the basement could use a flash loan to have infinite capital to liquidate MEV, right? Like that is a cool concept. Um, but I will also say that I don't think this capital requirement is nearly as bad as some people may think, provided you have permissionless entry into the system.
Mm-hmm.
And so this is where I think the difference is there's a very clear difference between like high frequency trading and like payment for order flow and the Robinhood Citadel jump
Where
trading
you
type
need to
thing.
like have like set up business partnerships to even get into the game.
Yeah. Yeah. And permissionless entry, I think, makes this like okay. And I think that the advantages of this type of like competitive system and using capital to fill users across chains, this intent-based system, they're worth it. And like the other anecdote I'd add here, in our network, like in the across relayer network, competition is actually most fierce with smaller size tickets where there isn't as much capital required. Um, but like, there's no reason why you couldn't actually have like let's call it organic or homegrown relayers only filling like the, sub $10,000 tickets here,
Mm-hmm.
and doing it better than Jump could. I don't think that's like an impossibility
Mm-hmm.
here. And I think that's
Mm-hmm.
kind of cool to think about.
Mm-hmm. Well, sometimes you also have these kind of anti-scale effects where, with certain strategies, you just can't deploy that much capital into them before you move the market, or you kind of like obviate your own access to them. So there is a way also where participants net, like, even if there is some kind of advantage to scale and compounding that happens, that people kind of like grow out of certain parts of the market, and that is always open to the new kind of like small entrant. Into the Bytecode is sponsored by Optimism. The Optimism Collective is building the open source modular software project known as the OP Stack, which allows developers to run layer 2 blockchains, while also addressing key governance and economic challenges in the wider ecosystem. Optimism is also leading decentralized grants experiments, like retroactive public goods funding, which recently granted 10 million OP to projects across developer tooling, infrastructure, and education. More recently, they had a major milestone by adding Coinbase's blockchain Base to also be governed by Optimism governance, and also contribute a portion of their sequencer revenues back to the collective. I've known the Optimism team for many years and know that they're dedicated to both scaling Ethereum and extending its ability to build better economic structures. So, if you're interested in learning more, whether you want to build something new or you want to apply for grant funding, then I encourage you to check out Optimism at optimism.io. So maybe let's take it to Oval now. What is Oval?
So Oval is MEV capture for Oracle price updates, for specifically Chainlink price updates.
Mm-hmm.
So what does that mean? Right now, Chainlink publishes price updates to the blockchain. They publish them to the public mempool, and those price updates are used to do things, right? One of the major things here is liquidations on Aave and Compound, and other DeFi protocols. They're used to do things, and there is MEV created by those things. So being more concrete, an Aave liquidation creates a MEV opportunity. That's currently getting lost. Like that MEV is going to
And
Ethereum
maybe
validators.
to say it more explicitly, so this price update lands on chain. It indicates that certain, loans are insolvent, and that a third party can come and call this function, liquidate that person, and get a piece, get some return for that. So basically, there is a market for who can snipe that liquidation as fast as possible. And that is kind of like another permissionless, kind of like perfectly competitive system where these searchers compete with each other, try to get the transaction in there. That means they pay as much as possible in their priority fees and gas fees. And that basically goes to the block builders and proposers in the core Ethereum or blockchain
Yep.
consensus mechanism, because they're basically choose the transaction that is most profitable to them. That's what they order as first. And so this all of that value is lost and captured by that layer of the ecosystem.
Yes. And to be even like more to put numbers around this,
Yeah.
Aave V3 has something they call a liquidation bonus, call it a bonus or discount. And that number depends on the asset being liquidated here. For Ethereum, it's 5%. And what it means is that if there's a liquidation that happens, so Chainlink price comes in and Chainlink price says this position should get liquidated. Aave, what they care about most of all is that collateral gets sold. Like otherwise, their system has bad debt. So they care deeply about that collateral getting sold. So they sell that collateral at a discount to the Chainlink price. That's the liquidation discount. So 5%. So equivalent, like what this is effectively equivalent to, it's like sending a Uniswap order for selling ETH with a 5% slippage window, but like no MEV protection, right?
Hmm.
And so what happens is you're gonna pay the worst possible price. Like no one's gonna buy the like fill you at a better price here.
Yeah.
And that's because the MEV supply chain is so efficient at like extracting this value. Um, so that's what's happening here, right? Like, and that 5% discount, like you just described, the searchers in the MEV supply chain are competing to buy that ETH collateral at a 5% discount. And they're basically competing to like a zero profit assumption. They're competing in almost a perfect competition sense. And so then they're paying most of that 5% that's going through the MEV supply chain and ending up with Ethereum validators at
Hmm.
the end. Um, okay, so it's not like it doesn't go anywhere. It does go to the Ethereum validators, but if we say they don't really need it, they don't really need this for Ethereum security, then it's kind of wasted, right?
Mm.
So how does Oval work to capture this? So we work with Flashbot's MEV infrastructure to essentially run an auction on the right to first use that Chainlink price update on a per protocol basis.
Hmm.
So what it says is it says for the first 3 blocks that Chainlink price is available, this is the number. We can change it from 3, but we think 3 is the right number. For the first 3 blocks, no one can use this Chainlink price unless you've gone through MEV.
Mm.
Um, and if you've gone through MEV is going to say, hey, 90% of the priority fee is going to be rebated back to Oval, which then gets split up and back to the protocol. Um, uh, and so like the MEV infrastructure through Oval is helping us capture this excess profit or this MEV. Um, or if you wait 3 blocks, the price is publicly available. So this is like a very elegant fallback. Um, if MEV breaks, if Oval breaks, whatever, if you don't think anything, if it doesn't work, the worst case scenario is you wait 3 blocks or like 36 seconds to get your price update. And so it's like a very simple, elegant product that we think would let something like Aave capture 25 to 50 million bucks a year in additional revenue, which is kind of cool.
So the delta between this and, the world we described was where the searchers were competing in the kind of public mempool, and they were all there's this kind of like middle ground here, which is they just use flashbots directly. In that case, there's an auction running, but so a single transaction or bundle ends up winning it, but all of that profit ends up going to the validator. You're basically injecting this additional layer here, this logic, which says we're going to run the same auction, but instead of giving all of the value to the validator, we're going to split this, and 90% of it is actually going to go back to the protocol that generated the MEV.
Yeah, so it's pretty cool and pretty nuanced, right? So um, ignore Oval. There is an auction being run. The auction is being run for like which block the validator is going to pick for that slot, right? And MEV Boost is running this auction. Block builders are building. So searchers are giving block builders their bundles. Block builders are building blocks, and then they're proposing their blocks with a kickback or like a bid to the MEV Boost software, which is then helping the validator pick which block to build. So there's this auction going on, which and I think a lot of your readers know. That's pretty cool. Um, um, if in that auction, so let's just for simplicity's sake say we had 2 block builders that were in this auction, and they each have a searcher send them the same bundle for an Aave liquidation. And the searcher is going to send them the same bundle, and they're competing with other searchers to like get that bundle included in that block. So those searchers are going to say, hey, the winning searcher bid says, hey, I want to pay, I'm just say 10 ETH to have my bundle included. Um, and they're the ones that pay the most out of all the other searchers. Well, if you run that through the current MEV supply chain, that 10 ETH, the block builders will then pass at least most of that 10 ETH on to the validator so that
Mm-hmm.
they win the block auction at the last layer. But what Oval does with Flashbot's MEV share, and remember, MEV share is kind of like a different set of infrastructure than the Flashbot's MEV boost. What MEV share says is like, okay, uh, my my 10 ETH bid, 90% of that 10 ETH needs to get paid back to this other address, right, to Oval. And MEV share sends that same bundle to all the builders. So it's all the same. So now the winning bundle is like, it's the same winner as before, but we've just basically taken 90% of that 10 ETH, so 9 ETH, and we've sent it somewhere else. So it doesn't end up going to the validator at the end. It literally is just like a stream diversion of
Yeah.
like the money. And so what's cool about this is from a searcher's perspective, they do nothing new. They actually, the way this works is a searcher just sends Oval their existing bundles. They don't do anything different than they're already doing. And we just divert 90% of the MEV revenue to Oval again for those first 3 blocks. And then after those first 3 blocks, it defaults back into the way things have always worked.
Yeah.
It's
That's
pretty
really cool.
technical, but
Yeah.
it's kind of like hacking MEV share and the supply the MEV ecosystem to just capture this revenue, which I think is kind
Yeah.
of fun.
And critically, you're getting the application, the smart contract is kind of like integrating with the system. And that's where the 3 block period comes from, where they say that only folks who include this 90, who use Oval and give 90% back, can actually see this new price update and liquidation opportunity within this 3 block period. And
Yep.
so as a searcher, you're like, the profit to me is the same. I want to execute on this as fast as possible. So you basically opt into this game that the smart contract that Aave has created for you. You send this over, and then and then what happens? And then the validator kind of has this option of, do I include this or do I wait? How do they kind of reason about this 3 block window?
Well, they can't, the validator, right? Like, validator gets their slot. So if you're the Ethereum staker, you're like, okay, so you're gonna mine this next block,
Yeah.
but you don't get to mine the next block in three. So you just have an instantaneous auction where you're
Right.
gonna whoever gives you the best block in your slot, you're gonna accept, right?
Yeah.
And so if your block, if all the blocks that all the builders give you suddenly have like 9 ETH less in them, in using my example, like if they have 9 ETH less in them than they did before, like you can't do anything. You're just gonna still
Right.
take the best block, right?
Yeah.
Um, and yeah, so and this is what Flashbots has done with like MevShare is kind of the infrastructure they have to uh, enforce that there's repayment instructions for where the searcher priorities should go in all the various bundles. Um, and MevShare is their infrastructure to enforce this. Um, the consumer version of Flashbots MevShare is what they call Flashbots Protect, right? Which is
Right.
the RPC endpoint. You put in your like MetaMask or whatever, and it will send all of a user DEX transactions to the MevShare infrastructure such that there is a 90% kickback back to you, the user, and you get your refund. The way to think about Oval is it's basically Flashbots Protect, but for protocol originated transactions,
Yeah.
right? And so we're kind of doing the same thing. And I can go into technically how we do it, but we're kind of doing the same thing where we're inserting like this 90% refund requirement for protocol initiated transactions. Um,
Yeah.
yeah, kind of cool.
It's pretty wild. Yeah, you basically like create this entirely new market structure that is that like everything converges on. Like the thing that for me was very noticeable with flashbots in the very beginning was that you could just see with the mechanism design that as soon as this thing goes live, every searcher is incentivized to opt into it, and every mining pool at that point is incentivized to opt into it. And very quickly, it just becomes like table stakes. So you just like everyone opts in and goes from 0% adoption to 90% adoption in like less than 6 months. And I feel like it's a little bit of the same here, where as a protocol, you basically it's clearly, strictly net good for you to do this. Um, as a searcher, if you're basically finding an opportunity using a particular protocol, you have no choice but to do this. Otherwise, you'd lose to the competition. And then as the validator, you have your one slot that comes up every once in a while, and you're going to take all the transactions that you can and put it in there. So it's like kind of the right market structure again, to me, it seems.
I mean, I like hearing that. I hope that's true.
Yeah.
I do agree that like the part of this that's pretty cool is um like for a protocol to upgrade this, mostly like there's always some nuanced detail, but mostly it's just updating a single address to insert the oval contract. And the oval contract really is just wrapping a Chainlink price update,
Yeah.
is the way to think about it. It's like wrapping this Chainlink price update for 3 blocks. And then after that, like it would be freely available. But for those 3 blocks, we're running this auction. And again, for all the reasons you said, all the searchers should want to operate within those 3 blocks because that's how they're going to extract their money. And that money goes back to the protocol. So I think it's really cool because this revenue is not insignificant and it can actually help make protocols more sustainable. So, and this is, I think, a bigger narrative about like MEV capture leading to better, more sustainable protocol design.
Yeah.
For example, like Chainlink deserves to get paid, right? And I, I don't actually know. I don't know if it's completely public. Like, what if anything, like Compound or Aave are paying Chainlink right now? But like, here's a way where if we're going to use the MEV that were captured from Chainlink price updates, Compound and Aave could actually share it back with their Oracle data provider,
Yeah.
and create like a sustainable ecosystem here.
Yeah.
And stuff like that is actually kind of cool.
That's super interesting. So rather than the protocol having to, we can build truly open, permissionless protocols that don't have an artificially added in kind of cut in the flow of value. Like they can be designed in that pure way, and then they can just basically house their system within this MEV protection, MEV share value chain. And that means that some of the value that's leaking out of the system will flow back to the protocol itself.
Yeah, exactly. Like the mental model I have, it's almost like um and we'll see how this evolves, but if you design a protocol, as your protocol gets used, you have like this MEV exhaust. Like I almost think of it as like a car with like exhaust coming out the back. Like there's just this byproduct that using your protocol creates. Um, and that byproduct goes up the more you use the protocol, right? And if we can develop mechanisms to capture that exhaust,
Yeah.
like you can use it to drive the protocol itself and to like
Yeah.
maybe pay for some of the input costs to the protocol or to create a revenue stream, to like another business model. And so I think this is like a pretty cool concept where yeah, like yes, you want to minimize MEV because it's kind of an inefficiency of your system. Um, but if you can efficiently capture the MEV that your protocol does leak, you can use it as a business model to drive your protocol in a sustainable way. I think that's like a very cool meta concept.
Yeah. How do you think of the limits of this idea? Like what does it apply to? So it seems like the way we're talking about it here, it's like any protocol that has MEV, which that generates MEV, which is basically any protocol that has um, that opens up economic opportunities to third party actors who basically in a permissionless market oriented way can capture those opportunities. So if you have any kind of thing like you have in say across where a relayer can come in and fill the order, um, anything like that creates MEV, and the protocol can basically in the most abstract sense think about like what kind of like on-chain data point is making that opportunity legible to this like marketplace, and hold that and put it inside of an auction and be like, whoever gives some of this back to us gets to use this opportunity.
Yeah, that is the way I think about it. That is the way I think about it, where like I think our depth of understanding about where the boundaries are here is still going to get much clearer in the next, year or two. Um, but yeah, being concrete, I think when there's value transfer, so I'm doing a swap, a single chain swap, or I'm moving value between blockchains. So swapping or bridging. Clearly, like there's a MEV component to that. Um, NFT like drops or mints or buying is another interesting use case here too. I'm really not like an NFT expert, but I do know that the original NFT drops were like super gas inefficient, tons of
Right.
MEV getting leaked. Like you could imagine capturing that, and maybe having like a fairer NFT auction, and how that would work is still like I'm not
That's
again the
so
expert on
it's like
like this
another
stuff.
way to solve the problem than having access lists or something like that.
It's a market-based approach to have instead of access lists. So you have all that MEV get captured, and then like the NFT collection can choose what to do with it. Maybe you pay back users, you distribute it equally. I don't know, right?
Yeah.
Like, but it's kind of interesting,
Yeah.
right? The things that I like, um, and by the way, I think there's a lot of MEV that gets leaked around these decentralized perp exchanges too.
Yeah.
Um, I think this is kind of like a sense of like a high performance MEV. Like it's like a low latency MEV, but I think it adds up to quite a big amount, and it'd be quite an interesting thing to research and study.
Wait,
Um,
how does that work? What's like the problem statement?
the the big problem statement with um, like any on-chain trading system um, is that on-chain trading fundamentally has some latency over like a Binance system, let's just say. So there is some block time, there's something, and it's getting shorter all the time, but there's like, it's not the same as Binance price is like real time. And then like on-chain trade happens and gets mined or processed at some delay behind
So there's
that.
always an ARB.
There's always an ARB,
Yeah.
right? And like synthetics very clearly had this ARB, a few years ago, where the Chainlink price, and so this is on Ethereum mainnet, so slower block times and Chainlink price updates not happening that frequently. But like Chainlink price would come, and then users in synthetics were able to trade like at mid, like they're basically able to trade at Chainlink price, with a fee on either side. But like if the real market moved before a new Chainlink price came, you could like arb the system. It was like,
Yeah.
okay, like I'll arb this. Um, and synthetics fixed this, or at least mitigated it. And I'm forgetting how they did that. One of your listeners will know and maybe can remind me on how they did that. But it wasn't exactly like the cleanest solution at the time, right? And generally speaking, having an auction here where you're like, okay, if you want to do a trade here, there's an auction to have somebody fill that trade. Where if you have people compete, they're basically going to pay that ARB back to the user or back to the protocol, let's say. And all of a sudden, like you don't really care that there's an ARB. Like synthetics wouldn't care if there's an ARB if they're running an auction that captures the value of that ARB and pays it back to them. Then they're just like, okay, cool, we don't care, right?
Right, right.
And so I think there's a big opportunity there to capture a lot of MEV from on-chain trading that emanates purely from this, like, I'll call it sex dex arbitrage.
Right. That makes sense. So maybe thinking about how this would apply to across, right? So in across, there's the origin chain, there's the destination chain. User says, I want to get I deposit token on source chain. I want to get token on destination chain. The piece of data that basically kicks off this market, filler activity is the fact that this user intent lands on chain, on chain A. I see that as a filler. I basically compete with all the other fillers to give the user their funds on chain B. How I'm thinking about how much I'm willing to pay there, my profit is what I would get from the across protocol doing the slow transfer and like the interest that they pay me for kind of like fronting the funds. My cost is, some underwriting of risk for reorgs, the time value of money, and like how efficient this marketplace is. And so there's some profit there. Obviously, Across wants to incentivize these folks because like the more of them that are around, the better the system works, the better value the user gets. So there's some like art here in like markets become more efficient over time. There should be alpha for these early fillers to take a chance, and like there's not that much volume and stuff. So they do this, but then at some point in time, Across as a protocol could come and basically wrap this like intent submission, right? And MEV share that and basically say that if you want to fill this within the next 3 blocks, your bundle needs to also include this other transaction that pays X amount of the profit back. Is that the right mental model for thinking about this?
Sort of. Like yes, but I would tweak a few things. So kind of like the way Across works now, and this is kind of funny because it runs a little bit counter to what I've been saying, but Across is only same asset to same asset bridging for now. Like we don't let you swap ETH to USDC. It's only like ETH to ETH. And that matters because like the price is stable. Like they're like one ETH is one ETH, right? So what Across does is it basically has a user suggest a fee, and like we run infrastructure to help the user suggest what that fee should be. And currently today, relayers are competing on speed to fill the user. So it's like, here's the fee. It's reasonably juicy. Whoever fills it fat first gets it, right?
Interesting.
Which is kind of interesting because our fees are really low right now, but they arguably could go quite a bit lower because we're not even having competition on that fee yet. Where we will be going, right, is running an order flow auction. So we'll run some auction for here's the user intent, who will fill this for the least cost. And one of the things that's interesting for us to think about is we are trying to run a sort of two dual variant like auction where we want to both have low cost and fast speed, but we don't want the user to have like a complicated process here. So there's a little bit of like nuance on how you kind of like navigate that. But I think going back to what you're talking about, generally speaking, if we kind of ignore the speed component for a second, what we're going to say is user says, here's what I want to bridge between chain A and chain B, who will do it for the lowest cost. And then there's like an infrastructure that runs that auction and passes the order to whoever said they do it for the cheapest cost, well ensuring that like that person actually does what they said they're going to do too.
Mm.
Right.
Yeah.
And so in a sense, this could be MEV share or MEV share like, but remember that like the Flashbots MEV share ecosystem is Ethereum mainnet only, right?
Mm.
So
Right.
um we're so like it's not there, like the MEV supply chain for L2s, like it's being figured out, let's say.
Yeah. And this is
Um
Suave, right?
So Suave, I think, yeah, this is very much like leads into Suave. And I also look at Suave as just this very cool, verified computation, privacy preserving computation environment where you could like build decentralized auctions in interesting ways. So uh, this is something I'm quite excited about because you could use Suave and like the trusted execution environment to actually program cool decentralized auctions. And maybe we could use those to basically run, let's say, an efficient auction for a cross-chain intents, something like that. Right? But
Yeah.
here we're getting way out there. This is like
Yeah.
stuff to riff on.
Yeah. Maybe we can leave that as a cliffhanger for next time. Hey, I'm going to make a small ask here. If you've been listening to these conversations and want to support what we're doing here, I would really, really appreciate if you could leave a rating and a review for the podcast wherever you're listening to it. This might seem like a small thing, but it will really help other people also discover the show. Thank you. I'm grateful to be able to do this and look forward to being here together again soon.